So on day 2 of us solving systems by elimination, only multiplying by -1 isn't going to get it done. So as I look at this, I want you to turn and tell a neighbor, for 5 seconds, do you have an idea of a number we could use? Lukian, what you thinking about doing?
Well, you can multiply the bottom by 3, or you can divide the top by 3.
So you could divide the top by 3, but then you're going to have a 2/3 x. That might be a little ugly. So let's multiply the bottom by 3 and see what happens. If I multiply everything here by 3, I get 15x, -3y, and 39. I like to just put one simple line through that so I know not to look at it anymore. All right, let's add this together. 2x and 15x. 17x. 3y, -3y. See ya. And 39 and 12. 51. Divide both sides by 17, and I get an x value of 3. Cool. Now I got to find y. So I'm going to slap it up in there. 2 times 3 plus 3y equals 12, which tells me that my 3y is equal to 6, so my y must be equal to the point 2. All right, so I'm saying my answer, where these two lines intersect each other, is at point 32. So let's test it out. So if I put in 3 here, I get 6. If I put in 2 here, I get 6, and 6 and 6 makes 12. Okay, works in the first one, but if it's where they cross, it has to work in both. So put a 3 in here, I get a 15 minus 2 is 13. Yeah. Check. It worked, guys. That's good. That's good. So does the idea I need to get something to cancel out, does that change? Same premise. It's just we have to think about some different factors, okay? So let's check out this one next. Turn and tell a neighbor what you want to do. James, what you want to do?
I don't know. I just know x is negative.
Well, here's which one looks like it's going to be easier to get rid of, x or y?
Huh?
Which one looks like it's going to be easier to get rid of, x or y?
Y.
Okay. So I got a 4y. How do I cancel 4y? What do I need?
You need to subtract 4y. Wait, no.
I need this to become what? -4y, right? So how am I going to do that? What am I going to multiply by?
-4.
Oh, okay, let's do it. So I get -8x minus 4y is 32. Let's add them together, see what happens. -11x, 4y and -4y, see ya. 32 and 12 is 44. Ooh, this is working out pretty nice, guys. So x is -4. Once I know what x is, I'm going to substitute it in for x to see what y is. Ooh. Y is 0. Where they cross. Let's test it out. 12 plus 0 is 12. Is that true? Yeah. Check. All right. -8 plus 0 is -8. Is it true? Check. It works. That's where they cross. They cross on the x-intercept. How do I know it's the x-intercept? Because y is 0. So I want you to turn and tell your neighbors on this one. What is up with this? How are we going to get this to cancel? Spencer! Wait.
Bottom by -1 2/3.
By -1 2/3. Yeah, we're going to get some ugly numbers. But it'd work, but we get some ugly numbers. Does anybody have another way? Titus?
Multiply the top by 7 and the bottom by -2.
So you're saying 7. And that, did anybody do a different way? Anybody do a different way? Nobody did a different way?
Oh, that's so smart. Wait.
Nobody did a different way? I was thinking maybe someone do something.
It doesn't work.
I thought maybe someone do something like this.
-3.5, but it doesn't.
A 3 and a -5. Anybody think that?
I mean, that would technically work.
Yeah, let's do these both and see what's up. Okay, the top one. I would get 35x plus 14y equals -7. And I'd get -6x minus 14y equals -22. Now, these equations look different, but are they still true equations? Yeah, if I multiply one side by one thing and the other by the same thing, it works out. So we're going to do this one, and then up top here, that would give us a 15x plus 6y equals negative 1, and a negative 15x minus 35y equals negative 55. These two look like very different problems at this point, don't they?
Wait, 2 times?
Well, we're going to do them both, and we're going to see what's up. Either way, though, are you guys seeing this? Our y term is canceling. Over here, our x term is canceling. You guys seeing that? All right, let's do it to it then. 29x equals negative 29. So x is negative 1.
You have to write negative 3.
Yeah, isn't it negative 3 instead of negative 3 for that? Because you didn't, it went 3 by negative 1 for the top equation.
I'm looking. 35x plus 14y equals negative 7. Negative 6x minus 14y.
For the other one, for the 3 and negative 5.
So I got 15x, 6y. Oh, yeah, I see what you're saying.
Yeah.
Yeah. Cool. Let's finish this one up, though. 3 times x, which is negative 1, plus 7y is 11. I'm going to cruise through this like two-step algebra because I think we should be pretty good at this stuff at this point. So I got negative 1, 2. Let's see what our answer is if we got rid of the x term. We got negative 29y is negative 58 divided by negative 29, so y is 2. And if y is 2, 5x plus 2 times 2 needs to equal negative 1. 5x is negative 5, then x has to be negative 1. I get negative 1, 2. What do you notice about our answers, guys?
They are the same thing.
Oh my goodness.
So either we're wrong twice or we're right. So let's test it out. A negative 1, 2. So negative 5 and 4 makes negative 1. Check. A negative 3 and a 14 makes 11. Check. We did it. That's the one point where those both things are true. You guys, we would not have to do both of these. I'm just showing you, like, if you got rid of the x term or if you got rid of the y term, it still gets you there, right? So the big picture is, remember yesterday we were talking about the swag and the lit fidget things? If you can get the same number of one, the only difference is in the other. Same idea, right? Just some bigger numbers now. So I want you to lean on that like basic premise to help your mind go to, okay, so what do I need to do to make that happen, right? Instead of saying, when it looks like this, I do this. In 6 months, it'll be gone, all right? I don't know if we ever talked about that before.
Probably less than 6 months.
All right. Let's get after it.